Hello, I want to demonstrate connection classifier. When working in Tekla, you can create parametric plugins, custom components, but it requires engineers' input which component to use for which case. For example, unitized element. It has top, bottom, corner joints, as well as horizontal and vertical T-joints. And you have thousands of such elements. Classifier finds possible adjacent connections for each selected object and afterwards classifies it based on user-provided setting file, which can be easily customized based on project-specific requirements for detailing. End result is report with classified connections and, most importantly, guides for parts for each particular joint. This information on its own isn't doing anything, but if you are an experienced user, you can easily use this as source for very easy further automation using Grasshopper or API. First, let's look at displaying results with Grasshopper. It's a matter of minutes of setting up a definition to display this report in Tekla. You immediately see what kind of joints and how many of each type you have in your model. You visually can see in which place you need to detail that can act as a guide for faster detailing. System works with anything. It doesn't have to be steel or aluminium beams, but it can be concrete panels. You can see how complex is your project. Here, for example, vast majority are simple, straight, corner or horizontal seams, with only some overlaps or corbels. While for more complex projects, you can see that detailing will take more time, since there are a lot of unique connections for whom you probably don't have parametric custom components set up in your library. This can help evaluate your project. It's relatively simple to set up a system where you choose a particular connection type, which plugin and attribute file to use. In this particular case, it takes 2 minutes to insert 1500 components to achieve LOD 350. Classification reports can also be linked together with calculation. For example, prefab seams, which are calculated based on stability model, where you have different forces. Calculation probably is done in spreadsheets, where you are calculating varied amount of embeds for each seam. From stability model, you know seam coordinates. From connection classifier, you have coordinates and seam type that can be matched together. You can merge this information to correctly calculate seams. Afterwards, you can automate parametric connection insertion with correct embed types and quantities.